A very good morning to all. In today's session, we are going to learn about the production function. So let's begin with the meaning of the production function. Production function refers to a functional relationship between the physical inputs and output. That means the input refers to a four means like land, labor, capital, technology, enterprise, etc. And the physical output is whatever the quantity has been produced in the market that becomes the output. So when we talk about the functional relationship, or we simply talk about the relationship between the outputs, between the inputs and output, we can always talk about the production function. In other words, we can also define this term as a technical relationship that study the material inputs on one hand and the material outputs on the other hand, or the other hand, that's called the production function. Material inputs includes the variable and the fixed factors of production. But when we talk about the standard equation, the production function is represented by Q, that is labor, and that's called variable element, and represented which is by L. So that means the you can talk about the quantity. We talk about represented by Q, labor is represented by L, capital which is represented by K. So that means the equation of the production function, which is equal, that is Q is equal to the function of labor and capital. So this is all about the production function equation. In the words of Winston, production function states of a relationship or shows a relationship between the firm's production, that is output, and the material factors of production, that is input, like land, labor, capital, technology, enterprise, etc., and the production, that is a quantity output, that is a quantity produced, that becomes the output. So when we study these two terms and how it correlate to each other, we always refers the production function. There are few assumptions of the production function. They both are useful. Factors of production, that is land, as a element. Factors of production are imperfect substitutes and the technology is constant. This is a graphical representation of the production function. So this is how the production function would be drawn, which referring to a Q is equal to a function of land and labor. That means the production produced is a function of land and labor. So with the usage or the combination of these two, you can say factors, that is land and capital, we can easily a particular we can see a particular company can easily produce the quantities according to their needs and requirements. For example, when there are 4 units of labor and the 5 units of capital, the equation for the production function is Q is equal to function of 4 and 5. So automatically, when we talk about the production function, the x-axis, the inputs has been measured. Inputs, we can talk about the land, labor, capital, technology, enterprise, and output, we can talk about the quantity produced. So while combining these two inputs, land and capital, we have produced the you can see the number of units, the number of output in a particular market. So automatically x-axis represents the inputs, y-axis represents the output which is used in the production process, and the x-axis where the output has been produced, that stands for output, and the Q is the production function of land and of labor and capital. Now we can come up with the two main parts of the production function. The first one is the variable factor and the second one is the fixed factors. Variable factors are those factors which can be changed during the short term period, and the variable factors is depends upon the level. It can change depends upon the level of output. So any increase in the variable factors, it means it leads to a more and more quantity produced or production or vice versa. So any employment of variable factors is not required when there is no production. So if there is no production, there is no need to add on or to add more and more variable factors in a particular to produce a particular output. So the variable factors include labor, power, fuel, etc. Next, we talk about the fixed factors. Fixed factors are those factors which cannot be changed in the short period or short run. The number of fixed factors always remains constant even when there is a zero production or when there is a no production. So the fixed factor could be a land, labor, buildings, etc. So production in the long run can only be increased when a particular when there is an increase in any of the variable factors, and that's become a production in the long run while using a combination of two factors, that is variable and fixed factors. Next, we can talk about the features of production function. The first one is complementary. A producer will have to combine these two inputs to produce, you can say, accurate output. And outputs cannot be generated without the use of these inputs. So when there is a need to produce an output, the two main inputs will be used, that is labor and capital. Next one is specificity. For any given output, the combination of inputs, it's totally been clearly defined that what type of factors are needed to produce a particular output. It should be clearly mentioned before any actual production will be started. Next one is the production period, whether it should be a long-term period or short-term period. Each stage of production is totally given some specific time. So the period of the production process is clearly explained to the production unit, and every step of production or stage of production is given some specific time period. So production could be completed over a long term period of time or it could be completed over a short period of time. So it depends upon the level of output or how much the output is needed to be produced. Next is the types of production function. The first one is the short-run production function. Short-run is a period of time where the output can only be changed by a change in any of the level of variable factor. In the short run, some factors are variable, some are fixed. So the fixed factors remains constant in the short run, like land, capital, plant, machinery, buildings, etc. Production can be raised by an increased level in any of the variable factors like labor. There is a situation when the output is increased by only increasing any of the variable factor of input and keeping the fixed factors constant. And when such situation would come up in a real scenario, and that will be called a short-term production function. And this relationship is explained by the law of variable proportion, where the production function with one input will be explained using this framework that's called the law of variable function or proportions. The next type of production function is the long run production function. Long run is a span of time where the output it can be increased by increasing all the factors of production, whether it is fixed, whether it could be capital, plant, machinery, etc., or any of the variable factor. So that is called the long-term production function, where none of the factors remains fixed. If all the factors of production is keep on increasing, then of course the out there as the output got get increased or could increase, it becomes the long run production function. So long run is enough time to enter all the factors of production, and all the factors of production are variable in the long run. Well, when we talk about in the short run, the you can see fixed factors remains constant, and the rest of the factors will become the variable factors to produce an output. But in the long run production function, all factors of production are variable, whether it would be fixed or variable. So the situation where the output is increased by increasing all the inputs of production simultaneously in the same proportion, then it's called a long run production function, and it is applied to by a conceptual framework which calls a law of returns to scale. So when we talk about the short run production function, we can be explained through the law of variable proportion, but the long run production function, it will be explained through the law of factors to returns. Next one is the production function with one variable input. So there are three main types of product, that is the total product, average product, and marginal product. So let's have an overview of these products. So the first one is the total product. Total product is always refers to a total quantity of goods which a firm has produced during a given period of time with a given amount of inputs, and that's called total product. Total product is also known as the total physical product, or we can also talk about other words like total output or total returns. Next one, we can talk about the like to understand this particular concept. A follow example could easily you can see understand if six laborers produce 10 kg of wheat, then the total product is 60. That means the number of laborers and the number of into number of units. That means 6 into 10, it becomes the total product would become 60 kg. A company can increase total product in the short run by focusing on the variable components only, because fixed factors will remain constant. So it is very important for the producer to focus on the variable factors. So if the producer is willing to increase any total product, he must focus on the variable components only. So with a span of time, both fixed and variable elements can be increased to increase total product. That means in the long run, the producer can use all the factors of production, whether fixed or variable, to increase the total product. Next concept, we can talk about the variable product, and the mathematically we can calculate the average product, which is equal to the total product by units of variable factor. So average product refers to an output per unit of a variable input. So AP is calculated by dividing the total product by number of units of variable factor. For example, if the total product is 60 kg of wheat producing by 6 laborers, that means the average product is equal to 60 by 6. It becomes 10 kg. And the 10 kg is an average product. That means the output per unit of a variable factor or input. Next, we can talk about the marginal product. So marginal product refers to any additional unit added to a total product when one more unit of a variable factor is used or employed, it becomes marginal product. So if any of the addition to the total product could happen when one more unit of the variable factor is employed or used, and it calculates the extra output per additional unit of input. So if any producer willing to produce any additional units of input, then definitely he has to, that will be added to produce any extra output, keeping all other inputs constant. So other names could be called, it's a marginal product, it's a marginal physical product, or the marginal return. And that's why the symbolically the formula would be called as MP of n, you can see factor is equal to the total product of n number of n units of factors by total product of n minus one number of factors. So that means a difference between the TP of n number of the factors minus TP by n minus one number of factors, it becomes the marginal product of n number of factors. And that's a formula which is being used to calculate the marginal product. Now we can come up to the relationship between the total product, average product, and marginal products. So the relationship between these terms can be explained using the concept of the law of variable proportion. That means the law of variable proportion with one input. As long as total product increases at an increasing rate, the marginal product is also increases, and it will goes on increasing and reaches until it reaches to a maximum point. Then at the second stage, the total product increases at a diminishing rate when MP declines. And it will continue until the total product reaches to a highest peak point. When total product reaches at its maximum point, the marginal product becomes zero. And this concept, these particular stages will be explained through the table and graphical. That means through the schedule and diagram, it will be explained this relationship. So let's begin the relationship. So this is, you can see the schedule, that how the average product is calculated, how the marginal product is calculated, that has been explained in the previous slide. So there are two main, you can say, variable factors has been given. One is a fixed factor, and the second one is the variable factor, that is land and labor. So land is remains the fixed, that is one for each units, and the labor that becomes keep on increasing, that is 1, 2, 3, 4, 5, 6, 7, 8. The total product is it's given is 2, 5, 9, 12, 14, 15, 15, 14. So the total product has been given in this question, that is the you can see 2, 5, 9, 12, 14, 15, 15, 14, and the marginal product we have to calculate. So 2 minus, there is no value in the upper unit, that is 2 minus 0, it becomes 2, 5 minus 2, it becomes 3, 9 minus 5, it becomes 4, 12 minus 9, it becomes 3, 14 minus 2, it becomes 2, 15 minus 14, it becomes 1, 15 minus 15, it becomes 0, 14 minus 15, it becomes minus 1. So if we look up the total product, the values of the total product, it keeps on increasing. But there is a point the total product reaches to its maximum or a peak point, that is called the 15. And then suddenly it keeps declining, reaches to 14. So it is a shape, it denotes a shape of the total product. It increases at an increasing rate reaches to a maximum or a highest point, that is 15, and it becomes stable for a some period of time and then reaches or declining to 14 units. So that's a shape, it denotes a shape. The schedule denotes the shape of the total product curve. Now we can come up with the marginal product. I already explained it how the marginal product has been calculated using the mathematical equation. So if you look up the values of the marginal product, it's definitely at the initial stage, it's automatically increasing. Then again, it drastically decreasing and reaches and touches the point zero and then becomes negative. And that's these value portray the shape of the marginal product, that it increases at an initial stage, then it becomes start declining or diminishing, then it reaches to zero and becomes negative. And of course, the stages is already shown the case of total product and the marginal product. So when we talk about the marginal product 2 to 4, it increasing returns, 3 to 1, it becomes the diminishing returns, and 0 to -1, it becomes negative returns. So in the above schedule or table shows that fixed factors of production, that is land, and the variable factors of production, that is labor. So the total production is initially increases, and as a result, the marginal product is also increases. But after the sixth units, we can talk of labor or the fixed factor, that is land. It becomes maximum. So like from the sixth unit, the 15 units of total product, and again on the 7 units of total 7 units, the total product is again the 15 units. That means it increases and reaches, the total product reaches to an highest point, that is 15. So the in this respective unit 6 and 7, the marginal product becomes 0. So as the 8 units of variable factor as applied or using up with the combination of the fixed factor, the total product decreases and the marginal product becomes negative. So this is how the stages has been defined from increasing returns to the negative returns. So let's begin with the graphical representation. So this is a graphical representation where the three main curves, that is total product, average product, and the marginal product curves has been shown. So if we talk about the stages 1, it shows an increasing returns. If you look up the shape of the three curves, that is total product, average product, and marginal product, stage 1, it's keep on increasing stage or increasing returns. But when we talk about the second stage where the total product and the marginal product and the average product, it keeps declining or the values of units are start declining comparative to the first stage. But when we talk about the third stage, both all the three shapes or curves, that is total product, average product, and marginal products. So when we talk about the total product and average product, it's diminishing. But in case of the marginal product, it's declining, diminishing to negative. So this is how the graph has been explained, and the total marginal product becomes 0 when the total product reaches to an highest point, which called a saturation point. When we talk about the stage 1, where the total product and average product and marginal product increasing, that point is called the point of inflation. So the diagram which show or the curves shows the three stages of production: stage 1, stage 2, and stage 3. Stage 1 shows when MP is greater than 0, average product is increasing where the MP is greater than the average product. So this is called an increasing stage. Stage second, when NP is greater than zero, automatically the average product is declining. That it means when NP is less than average product, but TP is increasing, it's just because the NP is greater than zero, and that's called the diminution stage. So automatically, when a average product and marginal product is declining in the stage three, it becomes the diminishing return. Even the marginal product is also increasing. Stage third, when NP is less than zero, the total product is declining. So if you look up the diagram, when NP is, you can say less than zero. When NP is less than zero, that means the marginal product becomes negative. Then automatically the total product is declining. So when the total product is declining, average product is declining, and when the NP becomes negative in that particular situation, and that becomes a negative stage. So stage one is increasing, stage two is diminishing, stage three is negative stage. So negative stage just because when the total product and average product is declining, that becomes the marginal product is negative. So this is how in this particular diagram the three main stages can be explained in this in this a very simplistic way. Three stages in law of diminishing return. So this is a more detailed explanation like stage one, stage second, stage third. So when we talk about these three stages, so stage one is almost you can say keep on declining constant. Stage two is increasing as a diminishing rate, and where the all the products where total product and average product is declining, and as a result the marginal product is diminishing. So the stage second is exactly show the law of diminishing returns. So let's talk about the stage one total product. If you look up the diagram and when you have a look on it, the total product increases at an increasing rate because the labor increases. That means the variable input increases. It means when the variable input increases, the marginal product it also increases until we increase the variable inputs of the factors. And when you look up to the labor, fifth and sixth labor, it shows a constant returns to a variable factor. So if you look up with the fifth and sixth stage units, so it will be a constant returns to a variable factor. When we talk about the second stage, the total product it's still increasing, but this time it is increasing at a diminishing rate because in the second stage it is increasing but increasing as a diminishing rate only. And it is because of a falling rate of the marginal product. And when these situations come up, this stage is called a stage of diminishing returns to a variable factor, which means when more and more labor is used, total product increases at a diminishing rate, but the marginal product would become declines. And when such situations would come up, it called a law of diminishing returns to a factor. In this stage, total product reaches to a highest point, which called a saturation point in the table also, in the diagram also. And when a labor is increased for few more units, the total product starts declining and ultimately the marginal product becomes negative. So when the more and more products are used, the total product is declining, and as a result, when total product is declining, the marginal product becomes negative. And when the marginal product is negative, it called a stage second of negative returns. So this explanation, a detailed explanation portray the schedule also, and it also portray the diagram as well. So when there is any short note being asked, what is the law of diminishing returns to a factor, you have to explain these three stages, and accordingly, and with the help of the diagram which has been explained in the earlier slide. So it could be summarized in the following points: increasing returns for total product in NP increases at an increasing rate. Decreasing return, TP increases but at a diminishing rate and NP starts falling. Negative return, total product reaches to the maximum, then fall, then NP reaches to zero and then becomes negative. What is the relationship between the average product and marginal product? There are also three stages in that. Average product, both average product and marginal product increases, but marginal product increases at an increasing rate as compared to the average product and reaches to a maximum point when MP and AP intersect to each other. That point becomes the maximum point. Decreasing and diminishing returns, marginal product starts falling, whereas the average product increases at a diminishing rate and reaches to its maximum. So if you look at the diagram, when marginal product is falling, average product is increasing when marginal product is declining, but average product increases at a diminishing rates. So when the total product is increasing, marginal product is negative. So when marginal product is falling, then definitely average product is increasing at a decreasing rate and reaches to its maximum point. So that becomes the decreasing and diminishing return, that is stage second in a case of relationship between the average product and the marginal product. When we talk about the negative returns, marginal product touches the x-axis or becomes zero and goes on negative, but average product will not go on negative. In fact, average product continues to fall or declining. And that stage is called third stage, and that is the negative returns to a factor. So this is how you can conclude the results between the total product and marginal product, between the average product and the marginal product. And the same explanation is also explained in a detailed explanation as well. Now we can come up to the law of diminishing marginal returns. So when we talk about the law of diminishing marginal returns in a production function, in other words, it is called a law of diminishing productivity, which states that one input labor is increased while the other inputs will become constant in the short run, and the marginal product from each additional unit of you can say labor is declining, and that's become the law of diminishing marginal returns. So if the marginal product is declining, and if by increasing and adding up an additional unit of the variable input, it becomes the law of diminishing marginal returns. The law of diminishing marginal returns is a short-run span phenomenon where the some inputs are fixed and while the others changes. It also explains the relationship between the increase in the variable input and the resulting change in output rather than other inputs, right? Fixed inputs. So the variable inputs is being increased like labor and capital. Fixed, it becomes fixed like land, machinery, Our buildings, marginal product, this is an additional output produced by adding up the more and more unit of the variable input. So if any producer willing to increase any more and more units of any variable input, then definitely it is planned to increase or to produce the additional output, and that's become the marginal product. Diminishing returns as more and more variable input is added, the marginal product will start to decline. Now we can come up to the production function with two variable inputs. So production function with two variable inputs shows a relationship between the amount of two variable factors of production and the quantity of output produced. So this function can be graphically represented using isoquants. So when we talk about a production function with one variable input, we talk about the production function in the short run. But when we talk about the production function with two variable inputs, we always talk about the isoquants. So when we talk about the two inputs, we talk about the isoquants, the curves which showing up the all the possible combination of inputs that produces the same level of output. If you combine a different span of time, the two inputs variable, that is the labor and the capital, and which produces the same level of output, it becomes isoquants. Two variable inputs. In this case, we are focusing on the situation where two factors of production can be changed or adjust the output. A common example is labor and capital, and the other inputs could be like materials or energy can also be considered in the production function of the factors of the variable inputs. Now, what is isoquants in economics? An isoquant is a curve which shows all the possible combination of inputs which yield the same or which achieve the same level of output. Iso means equal and quant means quantity. That means equal quantity it's to be achieved or it's to be produced. So an isoquant represents a constant quantity of output, and it is also called an equal product curve, production indifference curve, iso product curve, etc. So the concept of isoquant will be explained with the help of table given in the next slide. So definitely we as the production function is also explained with the schedule and the diagram. Same in the isoquant also being explained with the help of the schedule or table. So let's begin with this table. So if you look at the isoquant schedule, it's a combination of variable inputs, that is labor and capital. Units of labor L is also being given, and units of capital K is also being given, and the output of cloth meters. So while we combine to produce an output that is cloth, so these are the values has been given. That is 5 units of labor plus 9 units of capital, we get an output of cloth that is 100 meters. Same in the case of B category, a combination of B, that is 10 units of labor uh, and 10 units of capital, the output would become 100 meters. Same, a combination of C, that is 15 units of labor and 4 units of capital, but how much the output becomes the same, that is 100. Same in the combination of D, that is units of labor 20 units and the units of capital 3 units. When we combine these inputs, we get the output of 100 units. So what exactly? The whole schedule is showing the isoquant which refers to have all the possible combination of two variable inputs which yield the same level of output, that is 100, and 100. So the above table is based on the assumption that only two variable factors or two variable inputs or the two factors of production, that is labor and capital, are used for producing the 100 meters of clothes. So while combining a combination of two variable inputs, we get the output of 100 meters of cloth in each combination of A, B, C, and D. The combinations A, B, and C and D show the possibility of producing the 100 meters of cloth by applying various combination of labor and capital. So in this schedule, all the values has been given. The units of labor, the units of capital. So if the units of labor is goes on increasing, then we have to sacrifice the units of capital so that we can yield a same level of output of cloth. So isoquant schedule is a schedule of showing up different combinations of factors of production which yield the same level of output, and that's called the isoquant schedule. Now we can come up to the next concept, that is isoproduct curve. So through the diagrammatically, the isoquant is a curve showing all the possible combination of two variable inputs that produce the same level of output. So if you look at the diagram where we combine the units of labor and capital, and from using up the isoquant schedule, and once we draw the, you can say, downwards curve on this curve, or this is an equal product curve where all the possible where all the possible combination which yield the same level of output on the same curve, that is A, B, C, D, on the isoquant curve, and that becomes the isoquant product curve or production indifference curve, or the, you can say, equal product curves, and that's a graphical representation. So if we combine the 9 units of capital and the 5 units of labor, we achieve the 1,000 meters, that is same 100 meters of cloth, while 6 units of capital, 10 units of labor, we achieve the combination of B. Once we add up to the 4 units of capital and the 15 units of labor, we achieve the combination C. Same for the 3 units of capital and the 20 units of labor, we achieve a combination D. That means the once we increase the labor, we have to sacrifice the amount of capital, that is from 9 to 3, and the labor will get increased from 5 to 20. That means that on the all the possible combination, the producer yield the same level of output. Now we can come up to the next concept, that is isoquant map. So isoquant map is also a set of isoquants which shows the maximum attainable output from any given combination input. So these are the three isoquant curves: 100 units, 200 units, 300 units. So isoquant map is a set of isoquant which shows the maximum attainable, maximum achievable output from any of the possible combinations. So as the 300 meters, the isoquant 3 would be the maximum attainable output from any of the possible given possibilities of the combinations of inputs. Now we can come up to the properties of the isoquants. An isoquants like a verb on the right of the another isoquant represent the higher level of output. Two isoquants cannot cut each other. Isoquants are convex to the origin. No isoquant can touch other axis. Isoquants are negatively sloped. Isoquants need not be parallel. So let's begin with the explanation. Then isoquant lying above to the right of another isoquant represent the higher level of outputs. If you look up, the capital will remains the same as the isoquant shifts to the right, which represent the higher level of output from A to B. That becomes the one of the property of isoquant. So if you look up, the labor has increased from X to X1, and of course the capital has also been increased. You can say increase. That's why the isoquant shifts the rightward from point A to point B. That means it is one of the property of the isoquant. Next one is the two isoquants cannot cut each other. So if you look up in this particular figure, the isoquant IQ1 shows 100 units of output which has been produced by various combination of inputs. Same for the IQ2 shows a 200 units of output which also been achieved in two possible combination of inputs. On IQ1, we have A is equal to C, as you can see in the diagram, because they are on the same isoquant. On IQ2, then A is equal to B because they are actually they because the B is equal to C, and it becomes inconsistent. B, if the B is equal, becomes inconsistent, and since C is 100 and B is 200, then the isoquants cannot intersect to each other. So this is how the combination has to be done. Isoquants are convex to the origin. So isoquant must always convex to the origin because it follows the principle of the diminishing marginal rate of technical substitution. So the marginal rate of technical substitution is the rate at which the marginal unit of any input can be substituted for another input, making the same level of output, and that's become the marginal rate of technical substitution. So to gain additional unit of input, it is follow the principle to sacrifice some units for the another input, so that the same level of output could be achieved, and that's become the marginal rate of technical substitution. So if you look up that the same isoquant, all the possible combination has been shown. That means it is that whether to increase, whether you can say to increase the units of labor. Of course, we have to sacrifice the some units of capital. So it becomes the marginal rate of technical substitution. As shown, it's L12 is equal to L1 to L2 is equal to L2 to L3. But we have to decline the K1. K1 is greater than to K1, K2 is greater than to K2, K3. That means the capital has sacrificed as decreasing level, and labor has been increased. So that's called, and as a result, it convex to the origin. The curve, isoquant curve, is downward sloping, and it's showing a possible combination, and which refers to a same level of output. So the producer moved from A to B, B to C, C to D, or D, D, and so on. The marginal rate of technical substitution of labor for capital is declining, and such marginal rate of technical diminishes because two factors are not the perfect substitutes. So in this particular figure, every increase in the labor units, of course, there is a decrease in the units of capital, and that's the main reason that isoquants are convex to the origin. No isoquant can touch other axes. If you look up the isoquants, no isoquant can touch other axis. That means point K on the y-axis, which implies that any commodity could be produced with OK units of capital and without any unit of labor. This is a wrong because the firm cannot produce a commodity with one factor alone. Isoquants are negatively sloped as it is downward sloping, so automatically if any of the labor has been increased just due to a decrease in units of capital. So figure shows that when the producer moved from A to B, then of course to increase the level of units of labor, the producer has to decline the capital. So that means if the amount of labor increases from OL to OL1, but the units of capital decreases from OK to OK1 to maintain the same level of output, and that's why the isoquants are negatively sloped. Next one and the last one is the isoquants need not be a parallel. So the shape of such isoquants depends upon the marginal rate of technical substitution, where to increase the one level of variable input to decrease the at a decrease of the another variable input. So since the rate of marginal substitution between two factors are not perfect substitutes, so they not be necessarily same. So they need not when when the two factors, the substitution level between the two factors are not same, that means they are not need to be parallel. So if you look up, none of these three diagrams are not parallel to each other. Especially IQ2 is not parallel to IQ3 or IQ1. Now we can come up with the next concept, that is marginal rate of technical substitution. So as you can look up the mathematical formula, that is any minus any change in capital by change in labor, which is equal to the marginal product of labor and marginal product of capital. So that means the marginal product of each input. So any change in labor and capital, the ratio. So automatically the one unit of the variable factor has to be sacrificed, and it has to be reduced. So K is the capital, L is the labor. So while maintaining the same level of output or production, another factor of production is increased. So in order to increase or maintain the same level of factor, any one of the factor has to increase and another factor has to decline. So it becomes the marginal rate of technical substitution. It shows how you can replace one input with another input without affecting any output level. So that's become the marginal rate of technical substitution. So three journal shapes. The first one is the linear isoquant. So linear isoquants show up the constant rate of substitution between the inputs, where the one input can be substituted for the another input, and the other factors will remain constant. So convex isoquants indicate the rate of substitution between inputs, which is not constant, but it declines as the isoquant moves ahead. So if the shape of the convex isoquant is bowed inward towards the origin, but the shape of the linear isoquant is a straight line. Next is the L-shaped isoquants. L-shaped isoquants represent that they are perfect complements, you can say, which means they must be used in a fixed proportion to produce any level of output. And the graphs of the L-shaped isoquant consist of two straight lines meeting at the right angles. So let's have an overview about these three shapes of the isoquant, that is constant, convex, and the L-shaped. That become, these are the differences, and the shape will come on the next slide. So the isoquant type is linear, convex, and L-shaped. The shape of the straight line, bowing word, and L-shaped. Rate of substitution, in case of the linear, it is a constant rate of substitution. Convex is a diminishing rate because it's convex to the origin, diminishing rate would be there. But L-shaped, it's not applicable. When we talk about the linear isoquant, constant rate of substitution is a perfect substitute. Convex isoquant is an imperfect substitute, and L-shape is a perfect complement. So let's have a view of the shapes. So this is an L shape. If you look up the L shape, that is L, Q1 and Q2. State line is a state line isoquant, that is Q1 and Q2. And of course, it convex to the origin is a convex isoquant or hyperbola, that is Q1 and Q2. So these are the shapes of the three types, or you can say the shape of the three types of the isoquants. That is the L shape is the first panel one. Panel two is a state line, and panel three is which called a linear isoquant panel two, and the convex isoquant is panel three. Now we can come up to the next concept, that is economic reason of production. Economic reason of production shows a combination of you can see two main factors at a certain cost that means an economic meaning. So the areas outside the economic reason of production, it means at least one input has a negative marginal productivity. And the reasons which is marked on the left and the right side are called the ridge lines, which is called a boundaries beyond which one of the two factors is being overused. So outside the economic reason of production refers an inefficiency. That means company will better off use less of the one of the two factors, bringing the cost down while maintaining the equal level of output. So this is a diagram which you have a look, guys. You can look to achieve an equal level of output inside the area of the two ridge lines, upper and lower lines, which is one unit has to increase and the another unit has to minimize. But when we talk about the outer level of the ridge lines, it refers to an inefficiency. So the area which is inside the ridge lines, that means it is technically efficient and the production can take place in areas between these ridge lines. So these are the points where the A, B, C, D, E, F, G, H are the points where the MRTS is equal to 0. That means one input cannot be substituted for another input anymore. That means the minimum of one input required for the production of the other. So this is how the economic reason of production graphically has been explained. So the upper ridge line shows the marginal productivity of capital, which is 0, that is OM, and the lower ridge line, which is ON, where the marginal productivity is also 0. So technically, the area which is outside the ridge line, it is inefficient area, and the area which is inside the ridge line, this is the technical efficient, where the production can take place in the area between the upper and the lower ridge lines, and that difference is called the economic reasons of production. So that's all for today. Thank you so much for listening this lecture. I'll come up to a more and more interesting and important topics in the upcoming session. So till time, thank you and namaste to all.